That's good. Good evening, everybody, and welcome to the APS. Welcome to 2026. Yeah, it's only going to get better as the night goes on, because we have a really special event tonight. We are marking Benjamin Franklin's birthday tonight with a very special collaboration with the Library Company of Philadelphia, and also with an APS member, Joyce Chaplin, and her new book on the Franklin stove. And I really can't think of a better way to mark Franklin's birthday than collaborating with another Franklin-founded institution like the Library Company of Philadelphia, founded in 1731. The APS, of course, was founded in 1743. This is part of a long history of collaboration between these two institutions, and if you don't believe me, there's a book about it. And it's called Two Chips Off the Same Block, Benjamin Franklin's Library Company and His Philosophical Society, and this is the key part, and the saga of its 275-year relationship. So tonight is another chapter in this saga. The author of this book is John Van Horn. I'm sure he's somebody that you're all familiar with. John really kind of embodies this collaboration in a lot of different ways. John's first job here in Philadelphia was at the American Philosophical Society, where he worked on the Benjamin Latrobe papers. And then he went on to have a very distinguished career as the leader of the Library Company of Philadelphia. And I think can we now say 30 years at the helm? A little bit more than 30 years at the Library Company of Philadelphia. And in 2005, John was elected a member of the American Philosophical Society because of his incredible contributions to advancing knowledge through his leadership of the Library Company of Philadelphia and his institutional leadership here in Philadelphia itself. And he served on the Library and Museum Committee here at the APS. And so to introduce Joyce in tonight's event, I want to call John Van Horn up to the stage. And I should note that his pamphlet will be available for sale along with Joyce's book afterwards in the back.
Actually, it should be free. Copies available for one and all, yes. So, yes, thanks. I'm delighted to be here and to welcome you all to this joint program. We're delighted that it's being sponsored by Library Company and APS. As Patrick mentioned, we're both founded by Franklin. And we're meeting here in the month of his birth 320 years ago to celebrate that birth and to hear about the significance of perhaps his most famous invention. And so what could be a better way to start the year of the semi-quincentennial, as they call it. Our speaker this evening is Joyce Chaplin. She's currently the James Duncan Phillips Professor of Early American History at Harvard. Her wide-ranging scholarship, which encompasses science, climate, colonialism, environment, is evidenced by her affiliation with other parts of the Harvard University, the Graduate School of Design, and the Salata Institute for Climate and Sustainability. Dr. Chaplin earned her PhD in American history at the Johns Hopkins University in 1986, after which she spent a dozen years or so teaching at Vanderbilt before she moved on to Harvard University. She's made a special study of Benjamin Franklin and is probably best known for her book, The First Scientific American, Benjamin Franklin and the Pursuit of Genius, which came out now 20 years ago, 2006. Her other major works include a book on agricultural innovation and modernity in the Lower South, 1730 to 1815, Benjamin Franklin's Political Arithmetic, a materialist view of humanity. She also produced the Norton Critical edition of Benjamin Franklin's autobiography and published a book called The New Worlds of Thomas Robert Malthus, Rereading the Principle of Population. Her works have been translated into Japanese, Korean, Portuguese, Estonian, Chinese. Her reviews and essays have appeared in a lot of prominent publications, the New York Review of Books, Times Literary Supplement, London Review of Books, and the Wall Street Journal. She's won many book prizes, as you might imagine, and has won election to the American Antiquarian Society, the Massachusetts Historical Society, where she also serves as a trustee, and in 2020 was elected to the American Philosophical Society. And she also serves with me on the administrative board of the Papers of Benjamin Franklin, which is a major project at Yale University, which is co-sponsored by APS, and which is led by Ellen Cohn, who's also an APS member. Dr. Chaplin's most recent book, which we'll be hearing about this evening, is The Franklin Stove and Unintended American Revolution. During its preparation, she held an NEH postdoctoral fellowship at the Library Company and also a 2018 Guggenheim Fellowship. Her book shows how Franklin conceived of his invention as equal parts appliance and scientific instrument, a device that, by modifying how heat and air moved through indoor spaces, might reveal the workings of the atmosphere outside and explain why it seemed to be changing. And with this stove, actually there were 5 of them, it turns out, she says that Franklin became America's first climate scientist. So I'm very pleased now to introduce Joyce Chaplin.
Well, thank you so much. I'm really grateful for the invitation to speak here on the anniversary of Franklin's birth, the anniversary old style, before the 1752 calendar change modified his birth date by 11 days. But this is the original, and best, perhaps. It's a great honor to give this lecture, so thank you to the Library Company and to the American Philosophical Society for inviting me, and thank you all for being here this evening. I'm going to start, it seems appropriate, with a quotation from Benjamin Franklin, from a letter he wrote during the run-up to the American Revolution. "You will, I trust, excuse my so long omitting to answer your kind letter," Franklin apologized in March 1766, "when you consider the excessive hurry and anxiety I have been engaged in with our American affairs." Franklin's kind correspondent was Matthew Boulton, James Watt's partner in developing their historic steam engine, on which they wanted Franklin's advice, and the anxious American affair was a Stamp Act. Franklin wrote the day after Parliament passed the Declaratory Act repealing the Stamp Act, tamping down the transatlantic argument, at least for the moment. Franklin's priorities make sense, given his duties as a paid colonial lobbyist, and certainly as conventional regard events leading into American independence as central to American history. But given that the steam engine has had a greater impact on the world than the existence of the United States, it may be time to give the Industrial Revolution, including colonial Americans' contributions, to a comparable attention. Among other things, this reprioritization prompts a new look at the Franklin stove, the invention that qualified Franklin to assess another heat-fired device, the steam engine. So the cozy colonial wood fire and the coal-fired power source, you can see a tiny human there for scale. These share a history with consequences that continue today, which I put at the heart of my recent book on the full history of the Franklin stove. So, a confession about the book. Not that long ago, I'd sworn off Benjamin Franklin. I'd published quite a bit about him, and I said I was done. Yet here I am with another book because of a big thing I'd missed in my earlier work on Franklin. And it seems especially appropriate for him, a January baby, that this thing that I'd missed was related to winter and to cold. So a few years back, for another project entirely, I was reading about a historically bad winter, 1740 to 1741. This took place during what's now called the Little Ice Age, an era lasting from about 1300 to 1850, the last big climate change before our own, though it was a period of natural cooling, so the exact opposite of what we have now. But, like us now, people back then worried about how to adapt, especially to extreme weather events. At various points during the Little Ice Age, London's Thames River, Boston Harbor, and the Venice Lagoon, for instance, froze solid. Some cities, including London and here in Philadelphia, organize frost fairs. So that's what you see, this depiction on the left, where these are festive occasions with food, drink, and entertainment served up on ice. The package here on the right-hand side is a hunk of gingerbread from the last London Frost Fair in 1814. Someone kept it. Strange souvenirs. Less happily, the winter of 1740 to 1741 specifically caused crop failures that killed 13 to 20% of the population of Ireland, and that's a greater mortality rate than during the Irish potato famine, the Angata Mór of the 19th century. But when I was reading about 1740 to 1741, I kept thinking, I know those dates from somewhere, not from a winter necessarily, but I finally remembered that was when Benjamin Franklin invented his famous stove, not a coincidence. This was my first discovery about an undiscovered Benjamin Franklin. He was a climate scientist, the first in American history, and he was a climate inventor or adapter who made technology to overcome extreme weather during the Little Ice Age. Hence the central question of my book, can you invent your way out of climate change? Franklin was actually confident that he could. He's confident about a lot of things, not least this. He didn't, in fact, invent a stove. He invented 5 stoves. 2 in Philadelphia, 2 in London, 1 in Paris. So this was an ongoing project that lasted about 50 years, half of the 18th century, and most of Franklin's life. And it eventually involved a whole bunch of other people, so many of Franklin's family members, fellow and famous scientific experimenters, his landlady's daughter, many friends, fellow printers. And the printers were key in getting the word out about Franklin's work on heat. His printed work describing his first stove circulated before his death in 5 different languages, from Philadelphia to Dresden. Now, I'll go into all of these factors in greater depth, but along the way, what I want to emphasize is that this is a history I think is quite resonant for our own time, an example of the role of technical fixes in an ongoing crisis of climate change. To understand this requires understanding technology itself, its promises and its limits. Technology is not a force that operates independently of humans and human culture. It's always connected to them, so far. This is a point that I think keeps getting lost in many ongoing conversations about technology, which today we expect a lot from. Consider our often incoherent beliefs about technology. Electronic consumer devices are our friends. These glowing presences that make us feel both autonomous and yet connected, a really intoxicating combination. Meanwhile, AI is our rival, a hypothetically self-governing power that might do us in and replace us. Other new technologies are our saviors: electric cars, solar panels, heat pumps, carbon capture, geoengineering, gigantic rotating parasols out in orbit, sea barriers, flood protections, all the devices that are proposed as solutions to our climate crisis. But here's the thing. Technology has so far never operated independently from humans. Even autonomous systems have human preferences encoded into them, as scholars and critics of robotic systems and of AI keep reminding us. That kind of bias is hard for us to see often. It may be easier, I think, for us to see the human preferences of Franklin's era, because they're not exactly what we have today. So that's what I had in mind when I decided to do a study of Franklin's climate adaptation technology in the form of improved heating devices, so the 5 different stoves that he invested, see how they operated culturally, not as freestanding things that did something. I'll start with the first stove, the one that was prompted by that bad cold winter of 1740 to 1741, when Franklin began to worry about domestic heating in relation to the problem of available fuel to burn. No fuel, no heat, after all. Many colonists were becoming aware that, as had happened earlier in Europe, wooded areas were vanishing, and with them, everyone's easily restocked wood pile. Colonists had been taking out trees since the 17th century. Within a decade of its settlement, Franklin's Boston was entirely stripped of available wood. Franklin worried that his adopted city, Philadelphia, faced the same future. Wood, our common fuel, which within these 100 years might be had at every man's door, must now be fetched near 100 miles to some towns and makes a very considerable article in the expense of families. And that mile per year calculation was particularly ominous in and of itself, as Pennsylvania grew in population and its major cities spread accordingly. Where was wood for this large city going to come from, let alone out in the hinterland? Plus, given the little ice age, the longer and colder winters might get even longer and colder. In these northern colonies, Franklin explained, the inhabitants keep fires to sit by, generally 7 months in the year, that is from the beginning of October to the end of April, and in some winters near 8 months by taking in part of September and May. And that was the possible new normal that only made the problem of heating worse. Under these chilly conditions, generating greater heat with less fuel was a tall order, but that's exactly what Franklin and many others thought they could do. So, the first 2 stoves that Franklin invented in Philadelphia were designed to make household fireplaces more efficient, generating greater warmth with less wood, conserving Pennsylvania's diminishing stock of trees. Version 1. This was a fireplace insert, an iron firebox. You see it assembled down here on the left, but it arrived as a flat pack, like something from IKEA. And then you could put it together. You were better advised to get a mason or somebody technically skilled to come in and help you do that, and don't drop it on your toe, any part of it. But this iron box that you inserted into a fireplace would bring heat further out into a room. That large lip protruding would mean that the fire was actually burning further away from the chimney. And the metal sides of the box would radiate heat from tops and the top and the side, so less heat would escape up the chimney, and you keep your room with such a fireplace warmer. Version 2, also made in Philadelphia, was this firebox that you see here in profile, again, that extension out into the room, but with an air box installed within the chimney itself that was meant to, again, conserve more heat. It had channels cast into it that increase the amount of surface of metal that would be heated, and was supposed to, if correctly installed, keep hot air moving toward the room even as the smoke went up the chimney, and not the opposite. So the firebox plus airbox, a development that we're not quite sure when that was developed after 1740 in the first version, the very simple one. To make things more complicated, there's a possible version 2.5, which is the one surviving example. At the Mercer Museum in Doylestown, Pennsylvania. You can see that there's a slot cast into the back, perhaps to assist the air box and the movement of air. What you can't see is that there's also a hole around, a hole cast into the top for stove pipe. So quite a different design. We have no idea whether Franklin was involved with this, but it shows the continual tinkering that went into trying to improve domestic heating, trying to conserve firewood. One other thing to notice about this surviving example is that it is damaged, indicating that at least part of it worked. That if the top part of the plate was being heated and some of that air being channeled beneath it was colder, that would eventually warp and crack the metal itself. Now, those are the first 2 devices, and I'll talk about the next 3, but it's a real sign of Franklin's ambition that he thought that what he invented wasn't just a heating device. No, he was creating an artificial atmosphere, meaning an entire room kept warmer with less fuel and less trouble with smoky air than a regular fireplace managed to do. So Franklin helped to invent the ancestor of the kind of space we're inhabiting right now, where it's climate controlled artificially. A look at the before picture. These are people playing cards, standing around, courting in a window. Only the people right beside that tiny fire there on the left are actually being kept warm by it. There's no pretense that that is going to keep the rest of the room warm. This is an expectation that really increased over the 18th century due to Franklin and other people who were experimenting with how to do that. So this is a large public room in London toward the end of the 18th century, and that big gray kind of obelisk-like looking thing is a stove, and no one is huddled around it. They may be not quite as warm as we might expect to be in an interior space, but this is a very different expectation, that there's a heat source that radiates enough to keep people comfortable even indoors, even in winter. That's the after picture. So the before picture, the after picture. This is because the concept of atmosphere was being defined. It had been first defined in the early 1600s. And Franklin joined experimenters who began trying to create artificial atmosphere, first in small things like glass bell jars. To conceive of a controlled indoor atmosphere for an entire room was pretty ambitious, even if it only controlled two variables, air temperature and air purity. Those are still the really big important ones that we're enjoying right now. So I find it kind of amazing that Franklin and others were dreaming up this state of physical comfort when material conditions in the Little Ice Age might have invited fatalism. Well, we're just going to be colder. So Franklin's worry about Pennsylvania's supply of trees for fuel, his awareness of cold winters that might be getting colder, didn't deter him. He insisted that there were solutions for both problems, and he defined human well-being as the best measure of success in fighting climate change. Are people comfortable and healthy? Keeping warm and breathing fresh air were too beneficial to be ignored. I also enjoy the fact that Franklin's heating experiments were home-based. He used 3 domestic settings to invent his stoves, starting with his family's sitting room on Market Street in Philadelphia, which was a cozy little lab, right? For himself, his wife, children, random visitors. They were all lab rats for his first 2 designs. I wish there were a plaque there saying that this is the first of Franklin's experiments. It preceded his work with electricity. And I like how, if it was supposed to keep him warm and his family warm at home, home was where the laboratory was. And he continued thinking about his experiments in this way. When he was a colonial lobbyist in London, Franklin ran thermal experiments in the rooms he rented in a house on Craven Street, the one Franklin house that still survives. These he rented from a very forgiving landlady, given that he rebuilt her fireplaces and bored holes in her walls to monitor drafts. I don't know how those conversations went, but we know he did this. And the result was an improved kind of fireplace. You can still see some of what was being done here, especially the shrinking of the interior space with brick and then facing it with marble to make it look nice. And this is the Franklin house showing one of the fireplaces. In another room, they have a bust of Franklin in the fireplace, which I think is a little bit too on the nose, but there he is. So what he describes here, which I will let you read, was an improved fireplace with working components of iron that he commissioned to send warm air out into the room and then the smoke up the chimney. Same set of principles, but Franklin wasn't satisfied with this design either, hence Model 4 that he also did in London. This is a freestanding iron stove. It's a little vase stove there at the top. Again, it's something that you can put into an existing fireplace, keep costs down. You don't have to renovate the entire part of the house where you're going to have the heat system. But this freestanding iron stove would radiate heat from all of its sides. And in Franklin's own model, had a see-through door so that he could monitor the flames and the fuel. He recommended either special glass or isinglass so that you could watch how things were going. Model 4. Finally, when he was U.S. ambassador to France during the American Revolution, Franklin helped the Paris authorities solve a fuel crisis during yet another bad winter, 1783 to 1784, when he designed a little rotating grate to maximize heat with minimal fuel. So this is the final stove. So you see the 4th model over here, and then that rotating set of things on stands is this little device where you could put like one lump of coal and light it, put it in your fireplace and keep warm and do rudimentary cooking. A final attempt during emergency circumstances. Why this very cold winter? It's interesting that Franklin starts worrying about that as well as a solution to it. This cold winter in Paris in the 1780s had an odd dry fog that occluded the sun, which was why it was cold. The conditions threatened poor harvests and cold living conditions. The French authorities were worried about food and fuel shortages. As always in the Ancien Régime France, the measure of confidence in the government was the price of bread. And there was fear that if cooking and food got too expensive, there would be trouble. So heating needed to be kept as cheap as possible. Hence the authorities, including the Paris head of police, approached Franklin, who's a handy resident heat expert right there, asking him to design this emergency household heat source powered by a small amount of coal. So Franklin does this for them, and he does it on borrowed time, 1783-84. He was right then engaged in the peace negotiations ending the war for independence. As when he'd apologized to Bolton and Watt for not responding to their letter about the steam engine in 1766, he didn't have a lot of spare energy or time for inventions. But I think the Paris authorities knew that they had him over a barrel, right? What was he going to do? Say no? Given France's crucial support of the United States, he made a device according to their specifications, and there it is, model number 5. Only later did Franklin begin to try to think about why the winter had been so bad. The dry fog was a clue, he suggested, that volcanic activity way off in Iceland had sent a climate-modifying plume across the Atlantic. This, in fact, may not have been the bad winter's only cause, but Franklin was correct in his hypothesis about the role of volcanic forcing in climate change. So these are the little devils that created the bad conditions in Europe in the 1780s. The Laki-Gigar event lasted for 8 months with consequences that kill most people in Iceland. It was significant that it had effects that went through most of northern and western Europe. So Franklin is correct in his hypothesis about the role of volcanic forcing, that can actually cause climate change in an entirely different area, a different part of the world. And this hypothesis about volcanoes represents another one of Franklin's really good insights. Throughout his experiments with heating, he always connected the creation of these indoor atmospheres to the science of natural atmospheres. In his family's Philadelphia parlor, the place that I wish had a plaque on Market Street, he'd made key observations of convection, the tendency of warm air to expand and rise. That was central to his thoughts about an indoor atmosphere because convection was the way to fill a whole room with warm air, making it perfectly comfortable without. You don't have to crowd around a fireplace. You can be comfortable even sitting over by a window on the opposite side of the room. Franklin then used this principle of convection many times to explain the Earth's own atmosphere. If a room, why not the entire Earth? So he uses this principle to talk about the circulation of thunderstorms and atmospheric electricity. This is a little hard to read. Take my word for it, that this is what he's talking about. Why do storms move in the directions that they do? How do hot and warm currents of air affect patterns that are visible and sensible to people on land? So the circulation of thunderstorms, including atmospheric electricity, a spark moving Franklin toward investigation of that phenomenon. He uses this to describe the Gulf Stream's thermal patterns. And this, I'm very happy to say, is from an APS publication, from one of Franklin's late life essays. The third and final chart he did of the Gulf Stream, talking about how thermal circulation affected both ocean and air. And I like this illustration of the Gulf Stream, especially because he's there in it. He's down in the corner lecturing Neptune, of course. So another phenomenon he used, convection and the circulation of different kinds of things in atmospheres, the cooling effect of volcanic haze blown over oceans and continents. So this is not his own graph, but it does show what the Laki event did do back in the 1780s when everyone was cold in Paris. Franklin also hypothesized, just to go on with the way he's thinking about both indoor and atmospheres and how they interact, he hypothesized that trees cooled climate through transpiration and therefore had cooling capacity for cities especially. And he guessed that when humans burned fuel and generated smoke, they were changing the natural atmosphere. And indeed, our science has vindicated, alas, these hypotheses. It's also from Franklin's era, the Age of Enlightenment, that we inherit our techno-optimism, our hope that a single device might solve a big problem, silver bullet thinking. This faith in technology was part of an 18th century rage for improvement, the belief that planning and scientific knowledge could better the human condition. Franklin is an early incarnation of the charismatic scientific inventor who makes big promises. We live with this legacy, faith that, again, all sorts of devices are going to solve complicated problems for us, including climate change. But Franklin himself knew that climate change isn't easy to fix. It's what ethicists call a wicked problem, something with so many variables and so many mutating variables, it's hard to decide what to do first, and it's almost built into the problem solving that you make mistakes that you then have to correct, which Franklin did. He may have invented better heating, but each of his stoves had a flaw, at least another flaw. Another reminder, the technology is always embedded in and beholden to other human preferences. So for his first fireplace inserts, the Pennsylvanian fireplaces made in Pennsylvania, these may have saved wood, but the wood was from other people's trees. When Franklin calculated that wood per mile estimate of colonial wood consumption, he was projecting outward into territory that was still sovereign to indigenous populations, especially the Lenape Nation, whose land Pennsylvanians had begun to claim, first somewhat peacefully, then increasingly by intimidation and force. In 1737, the Lenape had lost land roughly equivalent to the size of Rhode Island, due to a colonial fraud called the walking purchase. This forced land transfer was the immediate background for Franklin's concern about rapid depletion of woodlands in precisely this area, right before he began work on his first stoves. Franklin knew of these circumstances not least because as printer to the colony, he printed the treaties between native nations and colonial authorities that were steadily eating away native land rights. The land appropriation and the first two Franklin stoves came about together. So this map was made by the same cartographer and illustrator who drew the diagrams for Franklin's stove pamphlet. So that IKEA flatpack assembly was done again by Lewis Evans. Franklin's first two stoves had another flaw. Made of iron, like all his stoves, they depended in Pennsylvania on the labor of enslaved people to produce them. Scholars have pointed out for some time that the colonial, my mic is coming and going, okay. The colonial iron industry was the initial foundation in North America of the kind of heavy industrial revolution usually associated with Europe. But by 1775, even before the American Revolution, the British mainland colonies were the world's third largest producer of unfinished iron, trailing Russia and Sweden, but accounting for 15% of the total global output. This iron industry was concentrated in the mid-Atlantic colonies, especially Virginia, Maryland, and Pennsylvania, and it frequently used enslaved workers. I suspected as much for the establishments that cast Franklin's stoves. And when I could finally go look at the relevant forge records at the Historical Society of Pennsylvania, after a long delay because of the COVID shutdown, there was Franklin's signature on a count in a book that also documented the work of enslaved Black people at the establishment that made his first fireplaces. So although famous for his eventual criticism of enslavement and support of abolition, Franklin never explained that his original Philadelphia-designed stoves were made with the labor of enslaved people. This is a reminder, not just of white colonists unthinking acceptance of enslavement, most of them, but of slavery's connections to the early phases of the Industrial Revolution in early America as elsewhere. And then a third flaw, and then I'll be done with the flaws, but a third flaw in Franklin's stove project. His last three stoves, designed in London and Paris, were made to burn coal, not wood. In his era, consumer decisions to burn fossil fuel made coal's extraction and eventual industrial use seem entirely reasonable. Most of the coal being burned at the time was for household heating and cooking, not to power heavy equipment, But this consumer demand, as it was initially, would open the way to runaway extraction and use of the world's first fossil fuel, which seemed reasonable at the time. In fact, it was a way to save trees. These are illustrations, first of all, showing the coal trade going into London, showing that that was almost unique. No one burned wood anymore, except maybe ceremonially if they were very rich, but everyone burned coal in London. And I like these trade cards that Franklin preserved from his time in London, indicating the two substances that his household burned for energy, cheese and coal. So for some reason he was very fond or felt dependent on the cheesemonger and the coalmonger. However, unattended, this search for better heating in Franklin's era was part of a seismic shift in material life. Again, the Industrial Revolution, arguably the most important revolution of Franklin's life. It's arguably the most important because with its historically unique rate of burning things, that revolution has resulted in the degradation of the Earth's atmosphere. So, alas, the Franklin stove was one of many steps, small steps in a historic transition into fossil fuel dependence. Designed to address a crisis of atmospheric cooling in the early modern period, his devices were part of a new kind of a material extraction and consumption that has created our global warming. True, only the decades after Franklin's death would the worst implications of all that burning become entirely clear. His generation wasn't aware, but parts of it were becoming clear during his lifetime. Franklin knew about the experiments that identified oxygen and carbon dioxide, for example, and he in fact knew personally the key experimenters who identified these elements. He didn't know because no one had demonstrated that it was the carbon dioxide that could generate hotter conditions by retaining heat within the Earth's atmosphere. I do want to note, however, that he absolutely knew about the other kinds of atmospheric pollution, especially from burning coal. He was appalled, he's on record, at deploring London's constant smog. London was already earning its nickname, Big Smoke. So Franklin complains to his wife back in Philadelphia, "You never get a sweet breath of what is pure without riding some miles for it into the country." He also described the situation analogically, implicating domestic combustion and the pollution of the great outdoors, another of his connections between artificial and natural atmospheres. "The whole town of London," he said, "is one great smoky house, and every street a chimney, the air full of floating sea coal soot." And it's for this reason that Franklin intended for his coal-fired stoves to have limited emissions. He really was running an experiment in scrubbing emissions on a household scale. He described this as reburning smoke, defining smoke as a suspension of wastefully unburnt particles, which indeed it is. Franklin said that domestic heating would be more efficient and emissions cleaner if the smoke was, as in his devices, channeled back into the flames, so the pressure of the warmed air that the stoves were creating, convection to the rescue again. And he was really obsessed with trying to do this. One of his friends calls him a universal smoke doctor. Now, maybe this worked. While Franklin's stoves probably did achieve greater heating power with less fuel, that part seems likely. This reburning of the smoke is trickier to assess as a success of his devices. Maybe Franklin achieved it. But really, somebody would have to build replicas of his stoves to truly test that out. And I encourage this. If anyone's looking for a hobby, contact your local iron foundry and get that transhistorical experiment underway to see how do they really work? Do they really work? What kinds of fuel, what kinds of conditions were necessary to make them work? The fact, however, that Franklin kept reinventing his stoves hints that even he was never satisfied. Plus, one of his last published works, again, in the APS's Transactions, was on the problem of smoke, where he writes to a doctor, no less, describing the problem of household interior air and how everybody's chimney did not function optimally. He defines 9 major problems with chimneys. And then at the end of all that, he says, sometimes they just don't work. Sometimes even the best heating systems defy all good designs, and redesigns for stoves, fireplaces, and chimneys just don't work. So reburning smoke, I don't know. But Franklin's achievement more generally was to recognize the problem of pollution in the first place. Particulate emissions from household burning are still a very serious matter. Household burning of wood and coal for heating and cooking, or from burning liquid fossil fuels generate things that are bad to breathe. Altogether, these kinds of particulate pollution are estimated to cause millions of deaths each year. It would have been wonderful had the warnings from Franklin's era, including his own, been taken more seriously as public health goals and as ongoing goals for heating design. Otherwise, Franklin's designs did have notable impact. He not only invented devices to be cast in iron, but he described them in a second medium, paper. And those printed emissaries allowed his designs and their principles to circulate more widely, most notably in the first pamphlet he printed himself, of course, in Philadelphia, to accompany the two Pennsylvania versions of his stoves. So you could buy a how-to guide, how to assemble it, where to order it, and how to make it work. This is the pamphlet that gets translated, and by the end of Franklin's life, circulates in Europe in 5 different languages, starting with Dutch. Eventually in German, in a big, massive, probably the best edition of his scientific works published, it happens to be in French, but including the stove pamphlet. And then in Italy, interestingly, in multiple editions. So Franklin's stove pamphlet has its greatest circulation in Italy, not in Pennsylvania, for instance. So these 5 editions, 3 of them in Venice alone. One very interesting I found in one of these editions was a diagram with instructions in Venetian, not in standard Italian, with instructions in Venetian telling you how to put this in your house, so indicating that they were cold in Venice and running out of fuel. Basically, that's the bottom line. And amazingly, Franklin stoves had their greatest physical presence in Italy, lasting into the 20th century, when you could still find them installed in places like train stations. Just a few years ago, there was a surviving example advertised on Italian eBay. It was partial and damaged, and I did not get it, but anyway. Also amazingly, I think equally amazingly, Franklin's work on heating, not the stove pamphlet, but descriptions of his actual devices. This is republished in London during the American Revolution. So a merchant who sold stoves based on Franklin's design praised Franklin's genius in making this improvement to everyday life for everyone, with no mention of the fact that Franklin was in formal terms an enemy to Britain right at that moment. So to return to my central question, can you invent your way out of climate change? We're all interested in that question. After seeing what Franklin and his contemporaries managed to accomplish with their more limited technologies and knowledge of climate, I think so. The creation of entire, comfortable indoor atmospheres was a massive and mostly successful project for the middling ranks and above in both Europe and in many European colonized places, making a great many people warmer despite the background conditions of the Little Ice Age. Franklin's era was exactly when expecting to enjoy a moderate temperature indoors became achievable. Let me offer a balance sheet and final assessment. What do we learn from this history of the Franklin stove? As an adaptation to climate change, I would say Franklin stove met only one of 3 desired criteria, something for us to keep in mind. First, the stoves worked, certainly enough to be adopted and imitated. But second, at least initially, they accepted social inequities rather than confronting them. And third, they validated a short-term solution, coal, fossil fuel energy with its own colossal drawbacks. They didn't know, but you want to go back in time and say, don't start burning that. So a good demonstration how climate change and trying to adapt to it is indeed a wicked problem. Huge, complicated, endlessly mutated, just bad all around. Which is why I think there's now a growing preference not even to think or talk about it. That's the wrong thing to do. But how should we think about it? How should we talk about it? And for all his faults, Franklin had some good advice about this. His famous almanac's alter ego, Poor Richard, adapted a Latin proverb, festina lente, to advise that to get anything important done, you've got to make haste, but paradoxically, you better go slowly. Make haste slowly. Since ancient times, people have translated this saying into visual emblems. So here, a tortoise, proverbial for its slow and steady progress, zips along with a sail rigged on its shell. And meanwhile, a dolphin, a creature built for speed, is tangled around an anchor, which slows it down. Note how each of these designs suggests that technology can improve on nature, right? There is a device here that's at work, but the nature matters too. Such images are reminders as well that device meant a visual emblem as early as 1375, only starting to mean a technical thing by 1570. So either way, humans are inventors. Left to our own devices, we can imagine many ways to do things with things. Hooray for us. I'm not proposing that the case of the Franklin stove or any example from the past tells us exactly what to do and how to move forward. But I do think there are enough similarities, resonances, echoes between the material problems of Franklin's era, climate change, resource depletion, pernicious social hierarchies, new energy sources. Similarities between those and our own state to be able to detect some useful prompts about detecting false solutions and compromised choices. But the case of the Franklin stove is an object lesson in another way, delivering a warning that above all, we can't delay. And I really find that interesting about the little ice age, that everyone talked about it, no one denied it was going on, and everyone thought there ought to be solutions now, now, now. So the urgency is real, even as panic is never going to be helpful. So festina lente, both haste and resolve are necessary. To fix a wicked problem, people must get moving, but with intelligence, correcting errors both old and new as they go. The worse the problem, the greater need for speed, but also care. In any techno-optimistic rush to invent a way out of our current crisis, remedies require the swiftness of a sleek dolphin, even as awareness of errors committed in the past must be a steadying anchor, which I hope my history of Franklin and his stoves will provide. Thank you.
We have time for questions from the audience. Yes, front row.
Hold on one second.
Excuse me, a little smoke in my throat. Why do you think only one of his stoves survived?
Hold the button down, or is it ready to go? You're good. You can hear me? Okay. This is actually common with a lot of iron objects. I remember walking through London with a friend who narrated how many fences used to be there before World War I and World War II, right? Because even in the 20th century, recycling iron anyway was a common practice. And in emergencies, obviously, people would tear down and melt down whatever they needed. And I think this is probably what happened with a lot of the stoves. I think as well, there are indications that if you wanted a new stove, you would get the price knocked down a little if you offered the iron maker your old device or whatever else you might have around. And I do think that the pace of innovation, I mean, the fact that not a lot of these survive is also indicating that people adopted new technology rather rapidly, which itself is quite interesting. I wish more of them had survived, though. Even as I know why they don't, it is too bad. We only have this one. And then a piece, there's a fragment of another one that was evidently used in a greenhouse run by John Bartram. So a very famous example of using heat as forcing for plants in winter especially. So we have... Even closer. Oh my God. Should I go over everything again, or did people hear about fences in London? It's amazing that we know as part of Franklin stove because the plate that survives is the front with the iron, with the sun on it. But again, just one fragment that kind of got buried in the rubble. So I do think that the pace of innovation was such that it could have even been a stove that Bartram once used in the house, and then they put it in the greenhouse.
Hi, thank you for a wonderful talk. My question might be just a little bit off base, but I'm curious about the Little Ice Age. And specifically, why did it end? Was it all the carbon dioxide that we started pumping into the air that changed it? Or would there have been a more natural, I guess, end to it?
One of the most terrifying things a geologist ever said to me was that we're probably still in it, and we have forced conditions so that it has completely masked the background geological state we're supposed to be in. That, I'm not quite sure about that, because the thing is, we're still not absolutely clear about why it happened. And we kind of regret the name for it, because geologists will also point out it wasn't a real ice age. And it should have been called something else so people don't get confused. Well, it didn't have the kind of geological background, so you can't imagine, woolly mammoths weren't sweeping across North America, and glaciers are not scraping across the landscape and so on. But the background conditions were probably had natural causes. We're not quite sure. Sunspots, different patterns of circulation. One proposal has been that episodes of calamitous decline in human population meant that there's revegetation of certain areas in medieval Europe during the Black Death and during the so-called Great Dying in Central and South America, due to decline of indigenous populations. And for a moment there, trees and other vegetation came back, and that had a cooling effect. We still are not quite clear. There's a very interesting and tellingly brief kind of description on NASA's website. Basically, no one is quite sure yet. If that answers your question?
When we come out of it, do you think that's because of the rise of the, burning of coal and the Industrial Revolution, or?
That is one hypothesis.
Yeah.
That depends on what theory you're putting your money on as to whether buildup of carbon dioxide in the atmosphere would adjust for that.
Right. Is there another one?
Another one.
Hypothesis.
Well, one of the hypotheses is about sunspots, and that is a different kind of effect on the atmosphere.
Okay.
But here's the thing. It is a thorny issue because, again, it was not a true ice age, but something really happened. But what?
Thank
There
you.
are patterns over time, right, of up and
Yeah.
down.
Yes. And so in Franklin's era, actually starting in the 17th century, people are constantly predicting, no, we're coming out of it. It's getting warmer, because it would be. And the Little Ice Age conditions, in some ways, the variation in temperature was not the only or worst problem, variation in precipitation, especially for an agricultural society. And so people would look at warm summers without a lot of rain and say, well, we're not in the same conditions anymore, but then there'd be a bad winter. So a lot of the debate was about whether it was a steady state, whether it was moving in any particular direction, which remained kind of in play into the early 19th century. Yeah.
Ben Franklin never patented his stove, but did he patent any of them, the other three over in Europe? Did anybody get patents, make money out of this?
So yes, in his autobiography, he has this high-minded statement that no, I bestow these on humanity. I'm not going to take a dime or penny. The thing is, he had granted the rights to make the stoves to a friend, and friend in the 18th century sense, meaning somebody who outranked him socially and monetarily, who was in a position to be helpful. So this person had loaned Franklin the money to set up his printing business, was his landlord at the time that he was doing the experiments with the stoves. So the gift of this was in a nexus of favors that had economic consequence. So no, he doesn't patent it, but there are other ways in which it is to his credit to have somebody else make the stoves. He never patents the ones in Europe. I think the one he designed in Paris he gave to the authorities. Again, I think they know right where they have him, that he has to go to negotiate with them and make sure they're happy. So he's not going to say, no, I don't have time to do that, and he just hands it over. He's very irritated at people who imitate his stoves, especially in London, and don't credit him. He doesn't want the money, but he wants them to acknowledge that it's based on his design. So that's where his ego comes in, but not in terms of getting kind of financial compensation for the design.
Another question there.
Did he say anything about, or write anything about the health effects of these various forms of fires in indoors?
Indeed. And one of his, thank you, because one of his big arguments is that it was better for you to be in an evenly heated atmosphere rather than get very hot by the fire and then shivery by going over in a different part of the house or the room. That was just bad for you. The body kept being shocked. He quotes a Spanish proverb in translation: if the wind blows on you through the hole, make your will and take care of your soul. And that it is very kind of early modern to think that these being buffeted by these different kinds of thermal elements could weaken the body. He also thought that being too hot was bad for skin, for teeth, for hair. He would say you can tell people, who sat by fires for much too long. So yes, generally the health was always a goal, and the comfort was a measure of that. I find it interesting that in all of his writings about, how do you tell if the fireplace is working? Other people writing at the time, including some that Franklin cite, used thermometers, right? That's how you can tell it's warm here and not over here. And Franklin says, no, you can use your body to do that. In a very late piece, when he's describing the smoky chimneys and basically saying they're always going to be smoky, he says that you may need to determine how warm the air is way above. And you could, in a sense, suspend a thermometer or hold it up there, but you could also get a stepladder and go up it and then use your body to tell how warm it is. So again, the human comfort and health is the essential measure of adaptation to climate change. I find brilliant. That's really interesting as an emphasis.
Great. Last question. Yes, sir. No, on the left.
Yeah. Me?
Yes.
I was wondering about what I understood the Franklin stove to be, which it may be incorrect, because when I bought my first house in the 80s, and it was a freestanding cast iron stove in the house, it was commonly referred to as a Franklin stove, and it wasn't an insert, and it worked great. And I thought, oh, it must be an evolution of or based on the design, but I'm not connecting the dots based on your talk.
Right. No, there are a lot of those freestanding potbelly stoves sometimes, the iron stoves, that are called Franklin stoves, even though they don't really resemble any specific design of his. So the vase stove, that round one that I showed, is not very big and not like the freestanding stoves people usually think about. But the thing is, I wrote a book about a fiction. I lied to everyone. I drew you here tonight because there's no such thing as the Franklin stove. It's not one stable object. I think it is his desire to keep trying to improve it. And I find it interesting that he's doing that within like a few years of his death, that he's really convinced it can always get better. Somebody can always improve it. We're not quite sure, how many models. I'm guessing 5. But I really would be fascinated and delighted if somebody proved me wrong about that and found a 6th, a 7th example, because I think the tinkering and the effort to try to do that is what matters. So your stove is a Franklin stove.
That's great, Anna. And I wanted to note something that you brought up in your talk. You probably saw that transactions that was dated 1785, and I don't know if you noticed where Franklin noted that it was written, at sea. 1785. So here he is, 79 years old, traveling across from Paris to Philadelphia, tinkering
Yes.
with this stove.
I'm going to add, he was supposed to be working on his autobiography, which is unfinished, and people lament, I'm glad he did the science writing myself. I
Must
think
have been
that
writer's
was,
block.
well, he decides that that is when he's at sea, because he's also experimented with the Gulf Stream. So I think he was just thinking of science at that point, imagining he would write the autobiography when he got back on land. But sea was leisure time for doing science.
No, I think he published 4 articles in that Transactions, which is
Yes.
remarkable at
Yes.
79 years old. So to mark this incredible life, on his birthday, I want to ask you all to take part in an APS tradition for his birthday, which is a group singing of Happy Birthday, led by our speaker.
This part I was not told about.
So, Joyce,
Okay.
happy
Happy birthday to you. Happy birthday to you. Happy birthday, dear Benjamin. Happy birthday to you.
Thank you, Joyce. Yeah. And thank you all. And Joyce's book is available in the back. She's happy to sign them, as well as John's book. Thanks.